Push that rock with some math. Let's talk about the definition of a logarithm. If b is a positive number and it's not 1, so it's either a number larger than 1, like say e, or pi, or 2, or 200, or it's smaller than 1 but positive, like say a half, or a third, or 7/8, then b to the exponent has some output. Likewise, if we say log base b of that output, which we now call the argument of the log, equals the exponent, which is the output of the logarithm. So notice logs output of exponent. A logarithm equals an exponent. What exponent does it equal? It equals the exponent you put on b in order to get a. So a would be called the power of the base, and p is the exponent here. Sometimes we interchange power and exponent together, and that's fine. Now, logarithms have a base. They have an argument, because all functions have an argument, the thing they operate on. So this is an operator, and it has an operand or argument, and then it has an output, and the output, notice, is the exponent. So logs are defined to be an exponent. And which exponent is it? Well, the exponent you put on the base of the log in order to get the argument. Now, notice that we talked for 2 weeks about exponents, so we know we can put in any real number, rational, irrational. But we're applying it to a positive base, so the output is always positive. So the argument of a log must always be positive, because the output of an exponential expression is always positive, unless you multiply it by a negative or something. But since this is b to any exponent, negative or positive, will get a positive power. So the argument is always positive. And that's very key to the definition of logs, that it only operates off positive numbers. Let's do some examples. So like maybe, let's think about 2 to the 3 equals 8. Well then, log base 2, because the base is 2. The power is 8. 8 is the third power of 2. You see why the confusion between exponent and power comes from. Well, what is the exponent that we put on 2 in order to get 8? Well, that would be 3. So the log is equal to 3. Okay. Let's evaluate some logs. So what does this equal? Well, we're looking for the exponent we put on 2 to get 1/16. Let's think about the powers of 2. 2 to the 1 is 2, and then there's 4, and then 8, and then 16. So this is the fourth power of 2. Well, going back the other way, 2 to the 0 is 1. So 2 to the negative 1 is the flip of this, 1/2, and then we get 1/4, and then 1/8. And so 1/16 is coming from 2 to the negative 4. So this must be negative 4, because 2 to the negative 4 is 1/16, then log base 2 of 1/16 is negative 4. What about here? Well, the powers of 81 get big, like 81, and then you square 81, it's large. And then the integer powers, like if I choose 81 to the negative, well, that's 1 over 81. So what's this? How are we going to get 3 out of this? Oh, it must be a root. So what root do we get of 81 in order to get 3? What root would go here? Well, I guess it could be some other fraction that's not a whole a fraction with a 1 in the numerator, but this is a root. It is the fourth root. So 81 to the 1/4 power equals 3, because 3 times 3 is 9, times 3 is 27, times 1 more 3 gives us 81. So this is 1/4, because 81 to the 1/4 is 3. Special logs. There's log base 10. So when we write just plain old log, and no base, it's usually understood in most contexts, although Wolfram Alpha uses this for the natural log. But most books and contexts, when there's no base written, it's understood to be base 10. So the base is 10. So this works with 10 to the p equals a. So that's called the common logarithm. And then there's the natural logarithm, that uses the natural base. So this works with e to the p equals a. So this is an understood log base e. There's your introduction to logarithms. Math made simple, some math.